Hello everyone, welcome to EDUARENA. In our previous video, we talked about continuous random variables. In this video, we'll talk about uniform continuous distribution. So, what is uniform continuous distribution? The uniform continuous distribution is a type of probability distribution where all outcomes are equally likely within a specific range. It means that every outcome has an equal chance to get selected. Let's look at an example of uniform continuous distribution. Let's say you're waiting for a bus and the bus is equally likely to arrive anytime between 10 minutes and 20 minutes. This means that waiting time is uniformly distributed over the interval from 10 to 20 minutes. From this example, we can say that time to wait for arrival of bus is uniformly distributed between 10 to 20 minutes. Now let's look at formulas used in uniform distribution function. The density function is 1 by b minus a. Expected value of uniform random variable is a plus b by 2 and variance is b minus a square by 12. Formulas may seem confusing right now, but let's look at an example question. It will give you a clarity. The example question is Delta Airlines quotes a flight time of 2 hours 5 minutes for its flights from Cincinnati to Tampa. Suppose we believe that actual flight times are uniformly distributed between 2 hours and 2 hours 20 minutes. So the first question is show the graph of the probability density function for flight time. So in the question, he asks us to plot density function of the graph. So as we know that density function formula is 1 by b minus a. So let's plot the graph first. Here b is 140 which is 2 hours 20 minutes and a is 120 which is 2 hours. So our answer is 1 by 20 which is equal to 0.05. It is very important to note that PDF shows the height of the graph, which means that in this problem, height of the graph is 0.05. The second question is, what is the probability that the flight will be no more than 5 minutes late? So, let's draw the graph first and let's note down the values of A and B respectively. As we know from the question that the flight will be no more than 5 minutes late means the flight will land before 125 minutes. Now, we have to use simple mathematics here. If we subtract the area between 125 and 120 with area between 140 and 120 and divide them both, we'll get our area between 125 and 120, which is our answer. Now let's find the answer. 125 minus 120 by 140 minus 120 is 5 by 20, that is 0.25, that is 25%. Now the third question is, what is the probability that flight will be more than 10 minutes late? Now let's draw the graph of third question. As we know, A and B points are 120 and 140, and in this question the flight is more than 10 minutes late, which means time is uniformly distributed between 130 and 140 minutes. Now here we have to find area between 140 and 130. So we will subtract 140 with 130 and we'll subtract 140 by 120 and divide them both. Now let's solve the question. 140 minus 130 by 140 minus 120 is 10 by 20, which is 0.5, and that is 50%. Now let's look at fourth and last question, which is expected flight time. Expected flight time is b plus a by 2, which is 140 plus 120 by 2, that is 260 by 2, and that is 130 minutes, which is 2 hours 10 minutes. I hope you like this video. Please like, share, and subscribe. Thank you for watching.